everyone. Let's get started with today's lesson, 324. How can I generalize the process? We've been 2 days now with making generic or rectangles, algebra tile rectangles, and we're going to try to simplify that process, okay? So today we're using generic rectangles to multiply. You have been using algebra tiles and the concept of area to multiply polynomial expressions. Today, you will be introduced to a tool that will help you find the product of the dimensions of a rectangle. This will allow you to multiply expressions without tiles. So yes, a lot of you are going away from using algebra tiles in your class, in the work that you're doing regularly, but we're starting to work our way away from it, but be careful with it, yeah. All right, so let's do a little review. First of all, use the distributive property to find each product below. Now, if you can kind of picture what this would be here, if we did this with the rectangle, then I'd have x squared over here, and then this side here would be 4x's, so 4x's, and then negative 2y, or minus 2y. Now, how do I do minus on a generic rectangle? And that's one of the issues we're running into with generic rectangles. And so we're kind of moving away from that, and we're going to try doing a just distributive property, which means we multiply the two parts right there. Okay, I'm okay with you doing that. I'm okay with you using distributive property when you run into issues like this, like we talked about in class today. That is fine. You do not need to necessarily draw a generic rectangle. Okay, draw a rectangle. You could say here are my 4x's, and then minus 2y's, and those are horrible y's, but we make them negative y and negative y. And then I multiply these, okay? So I'd have to multiply these values to get the area inside. So x squared times 4x, so that's 4x, and then x squared, since I'm multiplying, it'd be x times x, right? So 4x to the third power, and now don't show this right here on your paper. Just 4x to the third power, I showed it there just to make sure you understood what we were doing. Minus, now here I've got 2y times x squared. In that case, the number goes first, and then we try to go in alphabetical order, so x squared y. And that would be my number, that would be my answer. So distributive property, I just multiply these parts on the outside by every term inside. So please go ahead and use distributive property, write out letter B, this is 364, B and D if you notice, we're not doing A and B, or A and C. We're just jumping around a little bit. I'm trying to shorten it a little bit. So please go ahead and write letter D on your paper, write out the problem, and go ahead and distribute it. When you're done, unpause it and see if you got it right. Okay, so I'm going to multiply here. 8 times negative 4 would be negative 32w. And then I do negative 4w times negative, and you're like, that's not negative. Well, okay, fine, we do plus negative, now it's negative, okay? So you can do it either way. You can either say it's a positive, so I do negative 4 times positive 6, which is negative 24, so then I have minus negative 24, which would then turn into plus positive. See that? Or you can do the change it to plus positive first, or plus negative, and then I do negative 4 times negative 6, which is still positive 24, k squared w, plus, and then negative 4 w y. So that should be your answer. Negative 32w plus 24k squared w minus 4w y. Cool. Hopefully you got it right. All right, let's move on to the next part. All right, now I'm not going to make you draw this one, but I am going to make you watch. Just watch here, please, 365. This is not intended to be challenging, but I want you to think about it. Okay, this side right here, this is x and x, 1, 1, 1. So what do we have on this side here? 2x plus 3. Then on the bottom, what do we have? Well, x, 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 so 4x. 1, 2, 3, 4, 5, plus 5. So please write the area as a product and write the area as a sum here. Go. Okay, you should have come up with 2x plus 3 times the quantity of 4x plus 5 equals 1, 2, 3, 4, 5, 6, 7, 8. 8x squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 2 plus 22x's plus 3 times 5, 15. And there is my answer. Okay? Cool. You're like, okay, I don't get the point of this one. This is just prepping you here, okay? So please do write this down. Write that down based on what we saw right here, okay? Got it written down? All right. Now examine the following diagram. How is it similar to the set of tiles in problem 365? How is it different? So please look at that. And then I'll come back to this. Please look at this. Boom. And boom. Hopefully what you notice is that that and that are the same thing. They're just divided separately. So they took this part right here and this part right here and divided them by the type of tiles. Right here we have 8x squared. Right here we have 12 x's. Right here we have 10 x's. And right here we have 15, which is what you see right here. So this is what's called a generic rectangle. This is drawing the rectangle. Aren't you so happy? You get to draw the generic rectangle or draw a rectangle without having to draw all the individual tiles. Now, some of you are really good at drawing individual tiles. Some of you, holy cow, you couldn't really tell if it was an X or a Y or what they were, or a unit tile or an X-ray tile. So this kind of takes care of that. So when you do this work now, you are basically just going to draw a generic, by the way, generic means non-specific, kind of vague, kind of general. So this is a generic rectangle. It is not separated into tiles. You can just cut it into 4 parts. They do not need to be different sizes. I mean, if we look over here, do you see how these parts, like this part here is so much bigger than this part? When I draw a generic rectangle, they do not have to be different sizes. They just are going to be generic. And so then I put my values, and then 2x plus 3, and then I'm able to kind of fill out the values, okay? So they do not have to be the same size. They can just be a general, on your line paper, it's perfect. You can just, these are your lines across your paper. So just take 2 lines and kind of make a square or a rectangle. It can be a rectangle, but then just kind of easily take your space and do it that way, okay? And yes, I want you to try to take some space. Some of you need to learn to expand your work, because some of you are going to try to shrink it into one single line. Don't be ridiculous. But then some of you are going to make it gigantic and not use lines. So please work on your neatness and do lines. Now let's practice that, okay? So problem 367 diagrams like the one in problem 366 are referred to as generic rectangles. Generic rectangles allow you to use an area model to multiply expressions without using the algebra tiles. Using this model, you can multiply with values that are difficult to represent with tiles. Draw each of the following generic rectangles. Well, hold on, before we do that, let me show you that. So over here, once I do this, then I can say, hey, 2x times 4x, oh, that's 8x squared. 4x times 3, that's 12x. 2x times 5, that's 10x. And 5 times 3 is 15, which is what you see right here. And that's kind of what we've been working on all throughout these 3 years of like junior high, CC1, CC2, CC3, is preparing you for things like this, okay? So right now, draw each of the following generic rectangles on your paper, then find the area of each part and write the area of the whole rectangle as a product and as a sum. So you're going to do the product equals sum. Okay, so for both of them, draw it, sketch it, then draw it, fill it in. Well, sketch and draw are the same thing, so don't mind that. But then write the areas of product and areas of sum. That is your homework for tonight. Got it? So tomorrow we will start by reviewing your answers to this, and hopefully it makes sense. Talk to you later. Have a good night.